Hello, my name is Samson DeVol, and I will be presenting the Hearing Simulator web application research project I've been working on, which has been supervised by Patrick Donnelly, Oregon State University professor. So some motivation, I'm going to start with a quote from former President Barack Obama. Learning to stand in somebody else's shoes, to see through their eyes, that's how peace begins. I think this is a pretty powerful quote and drives a lot of empathy. But I would say that Barack Obama could have added to hear through other people's ears. So that's kind of the objective of this project, is to use technology to develop a better understanding of hearing loss that motivates empathy, accessible design, and prevention of hearing damage. So a little bit of background. Hearing is the perception of sound through an organ, such as an ear, by detecting vibrations through a medium, such as the air. So here we have a diagram of a human ear broken up into three sections: outer, middle, and inner. So there's two different types of hearing loss: conductive hearing loss, which happens to the outer part of the ear, or sensorineural, which happens to the middle and inner sections of the ear, but also commonly is a mix, which is called mixed hearing loss, and can occur to all three parts of the ear. But hearing loss isn't a one-size-fits-all, it is a spectrum. So here we can see there's a bunch of different degrees of hearing loss, ranging from normal to profound, as well as the attenuation or loss in decibels for that specific range of hearing. Now, audiologists use this tool called an audiogram, which is a chart depicting the range of hearing for a specific individual. So on this y-axis, you can see the hearing level or the attenuation or loss in decibels for, on this x-axis, a frequency range. So there's sounds are broken up into a bunch of different frequency bins, and an audiologist will score you on that specific frequency bin for both your right and your left ear. So in my project, the hearing simulator, the solution that I came up with to educate people on hearing loss is to mimic hearing loss using an interactive web application, which recreates an audiogram format. So we have to begin with an audio input. Here we have a sound wave, which is the disturbance of matter over time from the source of sound. It's represented as amplitude over time, and this is a complex sound wave, as it's not a consistent cosine or sine format. So then we have to use something called the fast Fourier transform algorithm, which extracts individual frequencies from that complex sound wave. So this is kind of complex, and I won't get into it too much, but I like to think of it as a smoothie. So if you're drinking a smoothie and you like the flavor, that's a complex taste. However, each individual ingredient that you can extract from that smoothie would be like a simple sound wave. Then if you go home after you had your Jamba Juice or whatever smoothie you like, you could recreate that smoothie with those ingredients. So that's kind of what this is. We have a complex sound wave, and we break it into the individual components for that recipe, basically. So then we need to filter these individual frequencies to make an example of the decibel range attenuation for that specific frequency bin. So for this, we're going to use a peaking filter, which boosts or attenuates volumes for frequencies within a specified range. So you can imagine that there are actually infinite frequencies making up a sound. And so in order to not have to manipulate each specific frequency, which would be impossible, we use ranges so that we can attenuate a bunch of different ones within that same area. So here we can see we have a low range frequency that's attenuated, and we have our high range frequency, which we're not going to do anything to. So this leaves us with our output, which we are going to use the inverse fast Fourier transform, the algorithm which combines individual frequencies into a single sound wave. So back to the smoothie metaphor, we're putting these ingredients together at home, and we're going to get that same sound, but we're going to have that attenuated frequency. So say you leave out the strawberries in your home version of the smoothie. So now I'm going to just show you a little demo video of the web application in use.
In this video, I will be walking you through the Hearing Simulator web application demo. To begin, we are going to walk through how to use the application, and then we will walk through some curated use cases. To use the Hearing Simulator web application, we need to begin by picking an audio file. I chose to use freesound.org, which is a robust collection of user-uploaded audio files. In this example, I typed in dogs barking into the search bar and picked one of the various options displayed. After we have decided which audio file to select, we can click on Choose Audio, which will populate our web page with the interactive audiogram. Now we are able to interact with each of the sliders, representing the attenuation in decibels of a specific frequency range. Once we are satisfied with the slider placement, we can hit the play button, and the manipulated audio will play back to whatever the device's audio output is selected as, for example, headphones or speakers. Now that we are a little bit more familiar with how the web application works, I'm going to walk you through a couple use cases. For each of these three types of common hearing loss, I'm going to show you what a professional audiogram would look like. Then I will play an unimpeded audio bite, and then I will play the manipulated audio representing that type of hearing loss. In this first example, I'm going to show you how we could recreate high frequency hearing loss. Now I will demonstrate a replication of someone suffering from low frequency hearing loss. In this third example, I will demonstrate somebody suffering from mid-frequency hearing loss. To conclude this demonstration, I'm going to recreate 3 stages of Ludwig van Beethoven's hearing loss throughout his life. These audiograms have been recreated courtesy of Patricia D. Shearer in the American Journal of Otology.
Okay, well, I hope that you enjoyed that demo video. I'd just like to go over some of the future work that's going into this project. There are some limitations in designing for various audio hardware systems. So kind of collaborating with audiologists and educators to decide on preferred hardware and use cases would allow us to better scale the decibel range levels, as well as provide stereo output for left and right ear. Another limitation, there are competing hearing simulators out there. About 6 months into this project, the CDC pre-released their beta hearing simulator due to high demand. So we have to differentiate a little bit, which we already do in mimicking the audiogram format and potentially offering real-time audio playback, because this technology is all built in React using Redux to manipulate the audio on the client side. Couple of acknowledgements for this project. Shout out to my project mentor, Patrick Donnelly. Go check out soundbender.org to check out all the cool projects. If you're watching this video, you're probably already there. Project funding, the Layman Fellowship from Oregon State University allowed me to pursue this research. Website contributors, Kimberly Markley, Ian Snyder, Blake Pugh, and support from the group Hacker Factor. They do really awesome stuff, so go check them out as well. Here are some sources throughout this presentation, and thank you for listening.